students, Assalamu alaikum. Welcome back to our GS class. In the previous class, we learned that when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. In fact, an electric current can be used to make magnets. Today, we can discuss about how to make an electromagnet. Take a long piece of insulated flexible wire and an iron nail. Wind the wire tightly around the nail in the form of a coil. Connect the free ends of the wire to the terminals of a cell through a switch. Place some pins on or near the end of the nail. Now switch on the current. What happens? Do the pins cling to the tip of the nail? Switch off the current. Are the pins still clinging to the end of the nail? The coil in the above activity behaves like a magnet when electric current flows through it. When the electric current is switched off, the coil generally loses its magnetism. Such coils are called electromagnets.
We will see a few applications of electromagnet. So where do we use them? You must have seen large machines used to lift up cars. They have an electromagnet in them. This electromagnet is so strong that it can lift the whole weight of the car. Electromagnets are also used to separate metal objects from a pile of junk. Now what if I tell you that they are used in the fastest trains around the world? Yes, the Shanghai maglev train is touted as the world's fastest train and it works on the concept of electromagnetism. Let's understand the use of electromagnets in simple devices such as electric bells. Yes, most of the bells we see nowadays are electric bells. Here's a very simplistic diagram of an electric bell. This is the inner structure of the bell. Let me first tell you the names of the basic components. This is a push switch, which is nothing but the switch we press when we ring the bell. This is a coil of wire wound around an iron piece. There could be two coils of wire wound around an iron piece as well. Remember, we've just drawn a simplistic version of the actual circuit. So it will act as an electromagnet when the electric current flows through the circuit. This is a battery and this is a striker which strikes this gong. That's when we hear the sound. So we can see that this is a circuit that can be formed. It's not complete. Why is it not complete? Well, we haven't pressed the switch yet. When we push the button, this circuit gets completed and the current flows from the positive to the negative terminal. But when the current flows through the coil, it becomes an electromagnet. This electromagnet then attracts this soft iron towards it. And in the process, the striker strikes the gong and the sound is produced. But notice what happens when the striker hits the gong. As soon as the soft iron is shifted away from its original spot, the circuit breaks. It no longer connects this wire with the terminal of the battery. And when the circuit breaks, the current stops flowing. So this electromagnet gets demagnetized, after which the soft iron goes back to its start position. This process will continue until the switch is open again. As soon as we release the push button, the circuit breaks and the bell stops ringing. That's the basic idea of how an electric bell works.